Welcome to Make Me Data Literate, the podcast that makes data intelligible from the Australian Data Science Education Institute. We're on a mission to make the whole world data literate. I'm your host, Dr. Linda McIver, and every week I'll interview someone with a wild and wonderful relationship to data. Let's see what we can find out. Hello, and thanks so much for joining us for another episode of Make Me Data Literate. We've had 2 economics episodes recently, and so this is a big change of pace, and I'm really excited to start talking about some conservation ecology. And to do that, we have Euan Ritchie. Welcome. Thanks so much for coming.
Thanks for having me.
I'm very excited. So to start off, can you tell us who you are and what do you do?
Sure. I'm a professor in wildlife ecology and conservation at Deakin University. And the what do I do part really is trying to understand how species interact with each other. So you can think about, as an example, predators and prey, and how that's really important to influencing what happens in ecosystems, the environment. And by having better information about those interactions, we can make better decisions about how to manage and conserve populations. So as an example, you might think of, red foxes or feral cats and how they interact with native wildlife like bandicoots or bilbies or some other native marsupial. And the things that we do in terms of fire management and other forms of management, if we can have a better understanding of how those interactions take place, we also therefore have better knowledge, which comes back to data, about what we might do to have good outcomes for our native biodiversity.
I love that idea that if you actually measure things, you can understand them and then use that to feed into the way you manage them and the decisions that you make. I feel like there's not enough of that in the way we govern, and I suspect, based on your Twitter feed, I think you feel that way too.
I think I'm in raging agreement with you, and it's a common sort of said thing that data is power and knowledge, and if we have data and good data, and I'm sure we'll get to that because there's data, then there's data. But if we have good data, it gives us opportunities to make better decisions and make choices between different decisions about which decision might be the best and the most effective and the most efficient. So everybody loves data or access to good data because it gives you that power.
Yeah, that's right. And also learning to identify, as you say, the good data and the bad data, and question the representations that you're shown and things like that. But I
Absolutely.
guess we'll come to more of that later. What did you have to learn to do what you do, particularly about data? Was there anything missing from your formal education?
Yeah, look, I did a decent amount of statistics in my second year of university, a whole year, in fact, and that's not necessarily always the case now for students undertaking similar degrees. I think it's fair to say that very few ecologists, environmental scientists, conservation biologists are probably prepared for how much statistics are involved in these fields and how sophisticated those statistics are. So, there's a running joke in ecology that ecology is not rocket science. It's much harder than that. And that's because there are all these moving parts. There's a lot of noise, and we often talk about noise in data sets. We're dealing with really complex, challenging issues, and we therefore need really good data, good robust data sets, and also in many cases highly sophisticated statistical approaches to make sense of what that data may or may not be telling us. So yes, I was given statistical training, but probably not to the degree that I needed, but very few are. And I think there's another important thing in terms of environmental science and ecology and conservation in general is that some people have a natural affinity with data and, with mathematics and things like that. And I wish I was one of those people. I'm just not. And it's something that I've sort of had to work at. But there's obviously other really important skills as well in terms of just being observant. So, having your eyes open and noticing things in nature and sort of questioning those, taking notes, and as is the scientific process, creating hypotheses and going, oh, maybe it's this or maybe it's that, and then undertaking an experiment or, observational study, collecting data, and then testing those hypotheses. So, I think most above all, it really is about questioning things, really questioning things. And I think that's what I love about having a science degree is regardless if it's the environment or anything in my life, I question it all the time and go, is that really true? And where's the data and evidence to support that? So I think that that's a really important lesson.
I love that. That's key, and I think it's not always the way we teach science, particularly in schools. We have a this my sort of one of my standard drums that I beat is that we tend to teach science as a matter of facts
Yeah,
and known
absolutely.
processes rather than as a discipline of questions. And I
Yeah,
think it's incredibly important that we do ask more questions, but that we ask rational, evidence-based questions rather than um, YouTube rabbit hole kind of questions.
absolutely. And it's challenging because as we collect more data, sometimes, of course, we challenge, long held theory and so forth. But that's a healthy part of the scientific process, right? That we go, actually, that's not true anymore, or there's the evidence for that, sorry, is not true anymore. And you collect more data, and that's a healthy way. But I understand that's challenging for the public because, they've sort of been told a certain thing operates a certain way, and some people might accept that. And then we as scientists come along and go, actually, we might have been wrong. It might be like this. But if we don't do that and we just accept things on face value all the time, that's far worse.
Oh, absolutely. And that idea that science is working when it comes
Yep.
back and goes, actually, the evidence that we have now is not covered by that theory, and it shows
Yep.
that theory
That's right.
we've just disproved it.
Yep.
So we got to move on and figure out
Yep.
something new. That's science at its best, and it's often
Absolutely.
held up um, by the less rational skeptics as see science is wrong
Exactly.
and
You're
science is
wrong. The
not
gotcha
working, and you're
moment.
like, no, this is what it's supposed to be. I was interested to hear you say before that that you felt like some people were naturals at mathematics and
Mm.
that you're not one of those people. And I, because education is my thing, I like to think that it's less a matter of innate ability and more a matter of how you've been introduced to it and
Oh, I
what.
completely agree. I think it's how you're taught, and nothing against my teachers in the past. The vast majority of my teachers were wonderful, and I think teachers in general are just the most amazing people, and they all deserve gold medals. I just think that in the past, the way that I was taught mathematics was probably very simplistic. There was one right way or wrong way, as an example, to solve an equation. We now know that's not the case anymore. We now know that even in primary school and even with my children, that different kids are taught to solve things different ways because that's how their brains work. And that just wasn't my experience. So I absolutely agree with you that everyone has the ability to connect with data and mathematics and the wonder of that too. Unfortunately, I probably just did, and I think it's very easy that it does float around in society. I think that this idea that some people are good at maths and some people are not, and as you rightly point out, it's probably more the opportunities that you've had, to really get help if you need to, or approach things from a different perspective. And I'm really glad that that's actually happening now in schooling, much more so than when I was young. So, yeah.
Yeah, I've seen kids come out of primary school saying that they're no good at maths
Yeah.
because they were low down on the times tables challenge, which
Yeah.
meant that they weren't good at memorization. That's not maths,
Yeah.
like,
Exactly. Yeah.
and thinking deeply about things and coming up with innovative ways to solve problems
Mm.
is not typically tested in
Yeah.
school maths, and so those are the skills that we need. Those are the mathematicians that we want, really.
Absolutely.
I promise I didn't set Ewan up with these talking points, but he's like hitting all of my favorite, like, yes moments. Is there one thing that you wish everybody knew about data? Like one thing that would just change everything if everybody understood that?
The short answer is no, only because data is only one part of the equation, and excuse the pun. So, we know with climate change, as an example, that there's been plenty of data, so much data that says this is what's going on, this is what's very likely to happen if we don't do this. Then, of course, it does happen, and often far, far worse than the scientists said it would, because the scientists, by their very nature, are generally pretty conservative. But things aren't changing to the degree that we would like, and that's a communication issue as much as a data issue. So I think we absolutely need, really robust data that we can have confidence in, and again, infer from that what we think is happening in our world, whatever the issue might be, and then make good decisions and actions that come from that. But the other equally important, part of that equation is communicating that, and getting people to actually, action, based on what that data is suggesting. So
It is
there's a whole bunch of data that I'd love people to understand better about, consumption as an example. So population size, I think, is a really interesting one in this context. So I often see debates online about the environment, and people will quickly say, oh, it's because there's too many people in the world. And I sort of recoil a little bit from that, because yes, there is a lot of people on the planet, but there's a tiny minority that are disproportionately using all the resources on the planet. There's a large number that are not. So there's an equity issue there. And really what's going on is a massive consumption problem. Now, that's not to say that if we keep increasing our numbers, there won't be problems. Of course there will. But that's an example, I think, of where, one piece of data just focusing on population size can be quite misleading, and arguably, has really, I guess, problematic cultural connotations and so forth about who gets blamed for what. So, yeah.
Yeah, it's about the storytelling, isn't it? It's about, how do we get this across and convince people the need for action. And we actually know that showing people data that contradicts their position actually embeds them in their position.
That's right.
It doesn't persuade
They
them,
dig
which
in.
is that quirk of psychology where you go, wait, that's not, I don't want it to work that way. But
Yeah.
it's a skill that I think needs to be part of every science degree, probably part of every degree.
Yeah.
But that's a different argument, I guess. What are some of the worst data mistakes you've seen?
Yeah, there's a whole range of different data mistakes. I think one of the most basic ones, and I'm sure you've seen this, is how data is actually presented. So, as an example, graphs are one of my pet hates. You'll see pie charts, as an example, that don't sum up correctly. So they'll have the wedges, and they'll have the numbers inside the wedges. And if you just do the simple math on that, you realize it doesn't equal 100%.
Yeah.
Having axes on graphs that distort the pattern. So if you've got two graphs with different axes, but they're shown as if they're the same, and then you look at the pattern, and of course one looks far more convincing than the other, that's a trick of the eye. And so that's a real problem. There's also the issue of what are often referred to as outliers. And I even remember in my undergraduate training being taught about outliers in data sets. Now, there are genuine statistical outliers that could be due to error, so data collection error, in which case they need to be removed from the data set, because otherwise, if you analyze those, they will give you a spurious finding.
Mm-hmm.
But there are also outliers that are legitimate. So you might have a population of animals, and one animal might be way taller or way bigger, or do something incredibly different compared to the rest of the population. And if you just throw that data point out because it affects your statistical relationship, because of course it skews it in one direction because it's this big outlier, that's actually not appropriate. That is a real data point, and that's actually telling you something about that population. Now, there's ways, of course, of dealing with that by presenting data sets in one with the outlier removed, one with it in it, and talking about that and what influence that's having on the relationship and and so forth. But yeah, there was this idea, I think probably more so in the past, but about actually deliberately removing outliers because it was inconvenient for statistical tests, and that's a big no-no.
Is that what you were taught to do at uni, to remove the
I
outliers?
wouldn't say I was taught to do it, but it was definitely something that I observed, and I think it was quite common that there was even statistical tests, to determine whether a point was an outlier or not, and then based on what that threshold was, you threw it out or not. And again, I think we've now come to realize, and maybe also with the sort of development of better statistical methods, more sophisticated methods that deal with outliers better and so forth, and deal with non-linear relationships as well. That's another big change in general. is that we sort of moved away from that idea of outliers, unless they're legitimate outliers. And then I guess another really important issue, particularly in my field of science, is observer bias and errors. So, as an example, if you were surveying a population of possums by spotlighting, so you have a torch and you walk along the road, person counts how many possums they see each night. If the same person does that each night, that's fine because they have the same ability each night. If another person does that, they might be much better or they might be much worse. And if you don't factor in that observer bias, again, that can influence your data set, particularly if you're collecting at different times of year, different locations, and so forth. So, yeah, thinking about how data is collected, how it's presented, and how it's analyzed are absolutely fundamental to, areas of that I'm in, so environmental science and ecology and conservation, and also because in many cases we often don't have many data points. So, if you're working on critically endangered species or threatened species or, some particular facet to do with ecology, we often don't have the hundreds or thousands of observations. We might only have 10 observations or 100 observations. And for some statistical tests, that's really up against it. So each data point matters. And so therefore we do agonize over that as well.
I think that's one of the fundamentals of teaching data science properly is that idea that, first of all, what is wrong with my data?
Yeah.
And what do I know and what do I not know about this data set?
Yeah.
And therefore, how many possible solutions are there to this, this analysis that I want to do? How many reasons might there be for what I'm seeing in the data? And instead of coming out with what we like to do in schools a lot and in university is to come out with the one answer and the perfect
Yeah.
curve and the like, here is the answer from this data set. That's not how real data works. And to teach that idea that there is uncertainty and we actually
Yeah.
need to spell out the uncertainty and to list the issues and really drill down into how many ways might I be wrong in what
That's
I think
right.
this data is telling me. It's a really challenging skill. Like,
It
it's
is, and
confronting.
it is, and it gets back to communication. And a lot of the sort of work that our group does is correlative, it's observational, and that's not to say that those approaches, aren't useful. They absolutely are, and in some cases, it's all we have. But again, therefore, you have to be really careful about the language you use. So you talk about, associations that might say this or might suggest this, but you can't come out and say this data shows this. It's like, we can't say that. We just can't.
Yeah.
But you see that all the time. You see that regularly, and
Oh,
particularly
yeah.
in the media and so forth. They say this data shows this, or if you eat bacon, you will get cancer. And then you read the study, and it says actually, if you eat this much bacon, you have this, tiny increased chance of getting cancer, as an example. So again, how we communicate, data and what it's actually saying is so vital.
It really is, but it's not. It doesn't fit very well with the soundbite and
No, it
the
doesn't.
clickbait headline and also and there is a reason why soundbites and clickbait headlines are so popular and so effective, because we like them. We like neat encapsulated certainties.
Yeah,
I want to know, is it safe to eat bacon or not? And the answer is it depends. I want to know, is it safe to get
exactly.
vaccinated or not? And it's like, well, it's safer than not getting vaccinated, but there's no such thing as 100% safe. Sitting here at my
That's
desk
right.
is not 100% safe. So
That's right.
it's not easy to kind of come to grips with the idea that the answer is maybe, and it depends.
Yeah.
It's not it's not the story we would like to tell ourselves.
No, people don't like qualifiers.
No, and they think it means that they think it means that the science is untrustworthy, but actually what they're getting is the best we can do with what we have at the moment. And I wrote an article many years ago about fair trade coffee and clothing and stuff, and the whole idea of fair trade. And one of the people I interviewed said to me, you have to make the best decision you can on the data that you have today, knowing full well the data you get tomorrow might show that that was a bad decision, and that's kind of science,
Absolutely.
as well. It's like you have to work with the evidence that you have today, even though the evidence that you get tomorrow might show that what you did was
Yeah.
the wrong thing to do.
And we've seen that obviously with the pandemic that, people have made decisions in, the absence of a lot of data, they just don't know
Yeah.
what's going to happen. And that's where we exercise what's called the precautionary principle. And we see that in the environmental world as well. It's like, we don't know a whole bunch of things, but we know that the risk is large if, if this thing is true, inverted commas, and we don't act, then the damage done is large. So then you exercise the precautionary principle. And obviously that's the tragedy of the climate change, sort of debate, inverted commas, is that, people say, oh, but the climate scientists are not agreed about climate change. Like, yeah, no, they're agreed that it's happening. They just argue about to what extent. And again, that's healthy. So
Yeah.
that's what the science is doing. But there's basically no one, that's, a climate scientist, a legitimate climate scientist who says climate change is not happening. So that's the difference. Yeah.
Yeah. It's frustrating to see that happening and to see the misuse of what we know. And so we've talked about data mistakes. What is your what's the worst data misuse, the deliberate misuse that you've seen?
Yeah, well, I mean, I guess fortunately, but also hopefully by design, I've not been aware of data misuse in any of my colleagues, and obviously not in my own group. And that's something that I, really reinforce, and it's part of undergraduate training about the ethics and just the absolutely critical, non-negotiable professionalism that you just don't, modify your data in any possible way. And that, there has been some really high profile recent cases, including in the environmental field. So to do with acidification of corals and the impact on coral reef fish, and some behavioral ecology work. And I'm not going to name the scientists because there could be legal action, but they've been found to have potentially engaged allegedly in scientific fraud, and these are really high profile pieces of work, published in big name journals.
Yeah.
So that's sort of, I guess, the cases that I'm most aware of, that you've got these data sets that are basically being made up, or the implication, the allegation is that they've been made up. So and that's devastating, because it again, as we sort of discussed before, it kind of taints other scientists and researchers, and it feeds that denialist, sort of narrative. Oh, scientists can't be trusted. They're just making things up, so they can all become rich and drive Mercedes Benzes and so forth. And knowing all my friends,
so many of the scientists
I know their cars. They're certainly not making any money out of climate change. So yeah, it is a real problem, because not only is it just terrible because the science clearly is false, but it damages the whole field and also the people in their labs. So I think that's another really important point, is that if you've collaborated with these people in good faith, and then all of a sudden one day you find out that all this research was made up, you lose your publication record overnight. You lose all these things overnight, which can be incredibly damaging to your career prospects through no fault of your own. So, yeah.
Plus, these results tend to linger long after they've been debunked. I mean, you only need to look at autism and vaccines to,
yes. Yeah, the Wakefield case.
Awful. It was debunked so quickly.
Yeah.
and yet people are still citing that research, and he's still talking about it.
I know. And I think the other worry is that I think some fields and data sets would be very easy to manipulate and not be detected. In other fields, that would be harder to do. So you think about my field as an example, where people are collecting data in the field, observations on animals and so forth. In many cases, there's no one out there, very few people. If someone was to fudge the data, it would be very hard to find out. whereas if you're obviously in a lab with multiple people and people are sort of seeing what's going on, and then people report something and, someone else in the lab says, oh, hang on, I know that didn't happen. That's not
Yeah.
what, so that's really concerning too, that depending on where you are, what sort of work you're doing, that sort of misuse of data and so forth, scientific fraud may or may not be easy, to undertake, which, is something that's obviously really unsettling.
And the case you were talking about before, where you said they were published in high-profile journals, so obviously, and they have review processes, and obviously the
Yeah.
reviewers didn't pick up any flaws. Is there anything you look for? You, as an academic, presumably you review other people's papers and stuff. Are there things that you look for in particular to spot both deliberate misuse, but also just naive
Yeah. There's a
misuse of
couple
data?
of things that are really important, I think, in, I guess, testing the validity of data. One is, can you repeat the experiment and find similar or the same results? So, and there's this big issue out there at the moment called the crisis of reproducibility of data sets. That a scientist will collect something, analyze it, write it up, and put it out there, and then another scientist does it and gets a completely different result. Now, there might be legitimate reasons for that, but there might not be. So that's a clear test for starters, is can you reproduce their work or not? And if not, is there a legitimate reason? So maybe the temperature was different in the experimental setup and something went wrong and, the animals behaved differently or something. Or was it something more sinister?
Yeah.
And then the other one is really when I see a data set, if it just looks too good to be true. And particularly in ecology, where we're used to pretty messy data sets. So if
Yeah.
I see a statistical relationship or a trend that's like incredibly strong and there's hardly any sort of uncertainty and error and so forth in that data set, immediately my hackles go up. And
Yeah.
most of the time, of course, it's fine. There's, it seems to check out, and you sort of you read that carefully. You might talk to colleagues and so forth who might have more expertise in a particular area and saying, well, does this make sense to you, this relationship? Would you expect to see that, and those sort of things? So you sort of do your due diligence. So that's the sort of process you go through. But of course, it's really hard to be 100% sure
Yeah.
whether something is legitimate or not. But yeah, certainly when you see really consistent, clear relationships, and particularly, of course, if you see them over and over and over again, that's certainly where some alarm bells would be going off for me.
Yeah, that's a theme that keeps coming up on this podcast, that people are like, if it comes out really neatly, if you get a really good result, that's where you go, hang on a minute, so
Yeah.
something's wrong.
And
It's like,
particularly in ecology, in my area, and in field-based ecology, where you don't have the power to control and manipulate everything. So if you imagine a laboratory setup where you might be able to literally control every single facet of an experiment, so you can literally reduce it to the one factor you're interested in,
yeah,
great. But that's not the real world.
yeah,
That's, we want to understand systems in the real world, and therefore you have to embrace noise. And there's a lot of noise in data sets and a lot of uncertainty. And so, yeah, when you don't see that in field-based ecological data sets, it's concerning.
yeah, and that's again something that seems to be very, very absent from the way we teach the use of data and the analysis of data, is that idea, teaching it with real data sets where they are messy and they're complicated and they don't make as much sense as we'd like them to make. What's the first question you ask when you look at graphs in the media?
What's the first question I ask? The first question I ask is probably how the data was collected. So what sort of methods were involved? So if someone's, again, particularly sort of emphasizing a really strong relationship and that they've got really strong evidence for something, obviously I'd be saying, was there a control? Was there replication? Those sort of really basic, boring but really fundamental things in science, because again, that sort of same old adage of, correlation is not causation and so forth. It's really important, depending on how forthright you're being with your language, therefore what evidence you need to really say that.
Yeah.
So I would always be looking at the methods for what someone's actually done, like how rigorous are those methods, and maybe have they come at this from more than one direction as well. So maybe they did a field observational study, and they sort of found something. Did they then try and potentially test that in the lab as well?
Yeah.
And if they can get the same sort of patterns emerging from multiple lines of evidence, maybe using different techniques as well, then of course again it becomes more convincing, and
Mm.
that's the rigor of science. And I think the wonder of science, is that we have these tools at hand and different approaches that, depending on how important something is, we can really sort of bring them to bear and really get at a question, to have more confidence. And it obviously comes back to how important it is. Obviously, if you're trying to develop the cure for cancer, you need to be really sure that this
Yep.
is correct. If it's something else that is far less important, still obviously you need to conduct your work in a professional and rigorous way. But you might not need to put as many checks and balances in place, because the ramifications of that work are just far less, in terms of if there's a bit of error and so forth, then maybe it's
Yep.
okay. But when you're talking about someone's life and the application of a treatment, you want to make sure it's right. So, those are the sorts of things we weigh up, I guess, when we're sort of looking at, science and how it's been conducted, and therefore, how legit it may or may not be.
And I love that the open data and open science movements are kind of shifting us to a place
Yeah.
where we can analyze someone else's data sets and see if we
Yeah.
come to the same conclusions. And I saw a quote years ago, something along the lines of, it's not, you can't say you have a result until you've got it at least twice. Like,
Yeah.
and it's this idea of science as fallibilism, where
Yeah.
you're not trying to prove something, you're trying to disprove it.
Oh,
And
exactly. Yeah.
that,
Anytime someone says this is proven,
yeah.
there's a small part of me inside that dies,
Yeah,
because
that's right.
that's not how science works.
Yeah, every time someone says something is proven, a fairy dies. It's it's and I see it in papers all the time, or in people reporting studies, going, the object of the study was to show that, and I'm like,
Yeah.
no, that's
Yeah. Yeah.
because
Automatically, you're not being objective if you're doing that. So
that's exactly right. You're
yeah,
looking for a particular
you're looking
result,
for a result,
then
and that's
you're more likely
where
to find it.
again, like these issues we discussed before, that's where you can get into these really slippery slopes and danger, where you're looking for a result,
Mm,
you're searching for a result, and that's not what you
mm.
should be doing as a scientist. You should have hypotheses and questions in mind, but then obviously when the data comes back, that's the data, and then you obviously infer what you think it's telling you from that, but you certainly don't go looking to show something.
Yeah, yeah. It's that that coming back to what you were saying about outliers before, that sometimes we think of faking data sets as being people making up whole sets of numbers, but it might be as simple as throwing out the outlier that
Absolutely.
messes up your nice neat
Yeah,
aha moment.
if you've got a regression or something, and you've got a data point that's sitting up in the the right corner or the left corner all by itself, it's going to change the slope of that line. That's just a fact.
Yep.
So yeah.
Yep. And I often call myself a professional outlier, because it doesn't matter which scale
Yeah.
you measure me on, I'm probably not normal. And so, you get people who have reactions to drugs, or respond differently in some way, or, don't do what they're expected to do when they use pieces of software. I'm really good at breaking software.
Yeah. Yeah.
And that, when you go, well, those outliers don't matter, you're throwing out the people who aren't normal, as well as any other
And not only that, you're
scientific
throwing out
implications.
opportunities to learn. I don't work on people. I work on non-human animals. But whenever I see an outlier, I get excited. And I was like, oh,
Yeah.
okay, so this individual's really different. What could we potentially learn from them? What does that open up? So I think, when you're throwing that, you're actually throwing out huge opportunities to learn, and potentially, even in the case of people, right, to potentially have breakthroughs, because like, oh, this person's different. And if that's an advantageous difference or something, that might benefit other people or people in general. So,
Right.
it's just a silly sort of notion to sort of, dismiss outliers. Yeah.
Yeah, and it's like, the experiments that go wrong sometimes are the ones that
Yeah.
teach us more. Like
Absolutely.
penicillin was
Yeah.
an experiment that went wrong
Yeah.
and turned out to be really vital. What is it that excites you about data?
I think data is just a subsection of science in that it's creative, in the sense that as a scientist, we are creating information that we didn't have before. So, you might be understanding the day-to-day habits and lives of a dingo that we just didn't know before. So I often think about science as quite similar to an artistic pursuit. It's actually inherently creative.
Mm,
And then you get to use that data to tell stories about what you think is happening. So that's what I find really inspiring about science, and also really profound and powerful, because, again, the area that I work in, I'm passionate about conserving species and using science to help make better decisions. So, um, yeah, the joy of just collecting data and finding out about an individual, about a species, and then being able to use that potentially is really exciting. And also just, I guess, opening a window for the public, because, I'm an ecological nerd, so I find all this stuff really interesting, but the public actually often do too. They
yeah.
just don't get to have that experience and connection that a lot of we ecologists do, because they're not out and about they're doing other things, and that's fine. So whenever we find out something super interesting about, the daily habits of a species or how it's interacting with others and so forth, it's just really fun. And, getting to share that sort of, that magic, if you like, inverted commas, and that information that we didn't previously have, that's really cool.
Yeah, it is. It's an opportunity, isn't it,
Yeah.
to really make change.
Yeah.
Um, I didn't warn you about this question because I only have been thinking about it the last day or so. And so we can scrub it if you if it's too much. But how do you maintain your optimism? Because, you know, we're seeing at the moment, especially this new government that was going to be so much
Yeah.
better than the old government and is still approving coal and gas. Like,
Yeah.
how do
It's
you keep going with that?
it's deeply frustrating. There's no question about that, and it's upsetting. And I don't think I'm alone, as anyone really who cares about the environment, of cycling through emotions of frustration that we're just not listening to the scientists and experts, anger because
Mm,
of what that means, and then sadness of the
mm,
inevitable outcomes of that. So I isolate between all those. But in terms of how do you get up each day and keep going, well, the short answer to that is, what's the alternative? And the alternative
yeah.
is you just give up, and things potentially are far worse. And I think that's another really interesting thing that sort of data helps us with, is thinking about the counterfactual. So even though things are really bad for some species, and some species are now extinct, some species are going to become extinct, there's a whole range of species that have been saved from extinction because of what really passionate scientists, members of the community, have done. So there is hope. And again, data does provide that hope, because it again tells you, well, okay, this is what we're up against, this is what we think is happening, this is how we might best manage that. And then, of course, we have to try and hopefully bring community and governments and other decision makers on board to act on that. Unfortunately, as you rightly point out, and as you've seen me rant about on social media and so forth regularly, it's just not happening at the pace and extent that it needs to,
Yeah.
for climate change and for addressing the other equal crisis, which is biodiversity decline and extinction. It's just not
Mm,
happening. But I just can't afford to give up. And I genuinely love wildlife and the environment and nature, and my family does. And I want them to hopefully be able to enjoy many of the things that I've already enjoyed, and even things about like the Great Barrier Reef. seeing how that's deteriorated in basically a quarter of a century, which is just a little bit more than half my life, that's profound. So I remember thinking in undergraduate, I was in Townsville being taught by people like Professor Terry Hughes, coral expert, being taught by Professor Stephen Williams, who's an expert in mammals and birds and reptiles and so forth at the wet tropics of North Queensland. They were both warning me in the mid 90s and early 2000s about what the possible impacts of climate change would be, either for coral bleaching and animals having to move up mountains as it got hotter because they'd run out of places to live.
Mm.
And as worrying as I thought that was at the time, I also sort of partly thought, oh, maybe they're just being a little bit, pessimistic and it won't be that bad. What they said has come to pass. And in fact, in some cases, far quicker and more severely than we would have hoped. So, yeah, it does show to me, it is really upsetting, but also that we can't give up. And so, and honestly, I don't know what else I would do if I did. So I'm definitely stubborn and incredibly passionate. So, yeah, but on a serious note, the vast majority of people I know working in the environmental conservation ecological arena definitely suffer from what I would say would be mental health issues, across quite severe to, mild. And I've certainly had my struggles with that, because if you love something deeply and you understand it deeply and you tell people, these horrible things are happening and this is all you need to do to fix it, over and over and over and over and over again, and it doesn't change, and then what you predicted happens, that's really upsetting. And I can only sort of imagine it must be very similar for people working in healthcare and so forth who warn of a disease, including during the pandemic, and how we might
Yeah.
tackle that. And they also have this intimate knowledge and they know what to do. They're just not being supported to do it. And then we know the outcomes. So, it's a similar sort of situation. So, yeah, it's a question that I'm often asked, and it's a really difficult one. But the short answer is we just can't afford to give up. And when we do get supported and use data and evidence, we can achieve wonderful things.
That's a magnificent note to end on. Thank you so much. This has been a fabulous chat. I've been looking forward to it for ages, and it's been really awesome to have you on. Thank you so much.
Thanks, Linda.
Thanks for listening to Make Me Data Literate. You can support the work of the Australian Data Science Education Institute at givenow.com.au/ADSEI. Tune in next time for more conversations with amazing data experts.